Hello, I reviewed this battery charger probably about 6 months ago. It's available from Aldi. In fact, it's on sale in Aldi right now. At the time of making this video, this is what's urged me to go on and get this done, because I have a few questions, particularly Frank from Reading saying, should I buy one, are they any good? And what Frank wants to do is to connect it to his caravan to keep his caravan charged up. And he said things on his caravan like the security camera and the security system drain cover, is this any good? Is this a good buy? And I couldn't honestly answer the question. So over the weekend I knocked up a utility on the computer for testing battery chargers. So I should be able to answer all your questions with this utility, and you can see what happens on the screen. So let's get on with it. Yeah, I was going to give you a quick view. There's the 4 instruments which are connected to that computer. You've got the scope. You can see there's the reconditioning charge as it's working its way up on the scope. That was displayed on the computer. There's the power meter. You can see the current and the voltage. You can see the current, it's the second one down, pulsing. It's that pulsing thing to get from 7.5 to 10, which can take a long time on a car battery while you're waiting to go to work. Then we've got the Regal. This is the battery simulator, so it's pretending to be a battery. You can see the charge and the load changing. So the Regal, and then above there is the iTech load. You can see the load current changing to up to 0.8 amps as it's going through this pulsing section of the charge from 7.5. As I said, if it gets below 7.5 it will never recover. And then down on the bench, amongst all this detritus, is the battery charger itself, connected up to the wires with the sense wires and everything else. So that's the setup. Okay, here's the utility I wrote over the weekend. I need it for other purposes, so it's not just for the YouTube channel, but since I was doing something similar I adapted it to this. And if we look on the screen, you can see there's the 3 instruments. We've got the Regal, which is the battery simulator, so that's generating a voltage, programmable voltage, pretending to be a battery, a car battery or an lead-acid battery or any kind of battery you like. We've got the iTech, which is the programmable load. That's pretending to be the lead-acid cells of the battery, so that sinks the power from the charger. You can set to a voltage, and then it will take the current from the charger, measure it, and then we can display it on the screen. And then we've got the Yoko, which is the accurate volt ammeter power meter. It's a very expensive piece of kit. It's up there. I'll flash up a video of the actual instruments in a moment. And so there we have the basic simulation of a flat car battery. And then if I just look at the AutoXS test, which is by writing a spreadsheet, we can put in a test for the start voltage, the end voltage, the actual load current, the duration in seconds, and the interval in milliseconds. So that's 2 seconds, and then the difference between the load constant voltage for the load and the battery voltage. Or clearly, when the charger starts charging, the battery voltage will change slightly because of the current being pushed into the battery, and that is to simulate that. And I've checked it and it works quite well. So by writing these scripts in Excel, we can do as many steps as we want for as long as we want, and simulate things like batteries going flat, a load, battery being disconnected, reconnected. We can put a big heavy load on the battery and discharge and go through charging cycles. We can make this as long as we want, as many steps as we want, and it's just a comma delimited called a CSV file, which is loaded into the utility. So I wrote a piece to load that into there. So there's the test. So we'll go through that in more detail when we've got the utility running, because it does display it on the screen. So if I just close that down, and we're running. Let's just zoom. No, we're not running, are we? So let's run. So let's run it. You can see the 3 instruments come online. Let's see if we can get a better picture of that. Yeah, so you should be able to see it a bit more clearly now. And if we just load a test, so I hit the load button, and then there's the AutoXS test and you can see it loads it and displays the parameters on the screen. You can change these during the test if you want to. That's just an overview of what the test is. So if now I turn the battery charger off, it's all connected at the moment. I'll do a diagram showing you how this is all connected, but just for the moment, take my word for it, because this is a video put up for people who want to buy the battery charger in the next few days from Aldi. And I'll discuss what's happening when we go through the test. So you can see up here, this starts up at 8 volts, ends at 8 volts, and maximum current is 5, and the duration is 200 seconds, and that's the desulfonation test. And so, assuming that your battery has run down to 8 volts, this is what happens. How the charger responds to the battery and what it does to it. Then we've got the bulk charge from 8 to 15.5, and the voltage that the charge should really cease should be about 14.4. It is temperature dependent, but around about 14.4. And we go from 8 to 14.4 in 200 seconds, and the current is 10 amps, and we're testing at a 2-second interval. Alright, so 2-second measurements, every 2 seconds a new measurement. Then we've got the float charge. The float is when the battery is gone off main charge. Hopefully the main charge will stop at about 15.4 or 14.5 actually, and then the float, as the charge is removed, you stop pushing current in the battery voltage starts to drift downwards. So this is that drifting downwards, and it would normally come down to 13.6 or 13.8 volts. So this is to check the behavior of the battery charger during the float. In fact, now let's leave it at 200 seconds. So the whole thing's going to take 1, 2, 3, 4, 5, 1,000 seconds. Okay, so it's going to be a test, so we'll skip on through. I'll put it recording. And then you've got the support charge, and this is what I was asked over the weekend, was like, if the battery starts at 13.3, and normally charged batteries would be 12.2, 12.1 when it's been standing. It's fully charged and it's just been left to stand and settle down. So this is a support charge, and we start at 13.3 and we ramp down slowly to 10.5. And an intelligent battery charger would, it's going down, there must be a load on, so let's put some more power into the battery, okay? And it would top up when necessary. So it sees the battery voltage drop down to below what is a fully charged battery and takes the intelligent decision, let's put some power back in her, shall we? And let's see if that happens. So without further ado, the battery charger is turned off, it's all connected up. I'll show you that at the end if you're interested, but now we're just going to run it. So hit the run button. You can see the graph has come up and it's all running. Okay, so we've got the battery voltage of 8 volts. You can see the blue line developing across the screen there slowly. That's the 8 volt charge up here in this area. And if I just turn on the battery charger, and you can see the battery charger is now flashing 7.8. So it's 7.8, and this is the analysis stage that they talk about, where it's checking what the battery is doing. So I've left that stable, so it's actually the voltage is 7.8 and the battery is actually 7.7. So we've got 7.7 simulated battery voltage down here. You can see down here, there. So we've got 7.7, which is 7.7 up here. So I think it's 90 seconds. I might just force, if I can't think of anything to talk about, I'll just fast forward. But you can see it's ticking along. It's stuck at 7.7 volts, and there's no current. The yellow line down here is the current, and you can see the amps of the charge amps up here, and you can see the load voltage. So when it starts to charge, this is the voltage at which it will maintain. So has it started doing anything yet? No, it's still flashing on the screen 7.8. Now look, it's kicked in, it's done its analysis, and it thinks you've got a motorcycle battery. Can you see the motorcycle at the top left of that display? So it thinks you're a motorbike. Let's just go in a bit zoomy on. Oh no, I can't go any closer. Right, I'll zoom that up on the video. So now we're charging, okay? So now we're charging at a current. In fact, we're not charging, we are actually pulsing. This is the pulse. Have I got anything here to show you that? Yeah, here we go. So that's what's happening on the scope, and this represents, this is a third of the, this is a full voltage is 10 volts out of the output of the iTech load. So you can see now, look, it's pulsing, and each pulse is 1, 2, 3, 4, 5. It's about 500 millisecond pulse with a quite a high edge on it. Look, you see that? So it's zinging the current in, and this is supposed to be the desulfonation recovery going on. You can see it on there. This is what's actually this is the live current from the scope. This is connected to my scope at the moment. And if I just slow down that, can I do that on here? 500 millisecond scale, auto, horizontal. There we are. Let's make it 200. No, it's not going to let me. That's 200 seconds. That's no good. 200 milliseconds. There you go. So you can see it pulsing. So it's doing the pulsing. You can see it on the screen. But now it thinks it's a motorcycle. Look at the actual display. It thinks you're a motorcycle. So the first thing is, this battery charger always requires your intervention to say, hey, this is a car battery. Bloody hell, get on with it. Otherwise, it's going to be stuck at, what current we got? We got 0.8 amps, look, up there. 0.32 amps, in fact, 0.37. But that's an average of this pulsing. So this is a pulsing sort of to stop gassing and trying to get the battery voltage up. And you can see once the battery voltage starts to climb, this pulsing behavior will stop. You can see the voltage climbing up here. It's going up to nearly 10 volts, actually 9.72. And when we get to the a bit higher, you'll see the pulsing stop, and then it will go into charge mode. But in the interim, it's I'm just going to press the car button. So here's my finger on there. Let's put it into car mode, and you can see it's gone straight to 3.8 amps. So when the voltage reaches 10.4, it will start into what they call the bulk charge, and there's nothing much to see down here anymore because it's a stable 3.8 amps. So it's a 3.8 amp battery charger. I've tested 2 of these and they all 3.8. This is a bit like commentating a race, actually. Yeah, some volts is coming up to the line. So we're up to 11.68, which is still a pretty flat battery. So we're bulk charging, which is the right thing to do. You can see. I wonder if I can get that view a bit bigger for you. There you go. So that's what's happening now. You can see it down up the side here is the units. So we've got 3.8 amps on the yellow, and we're running at 12.2, 12.5 volts. If we go back to the standard plot, 12.72, okay, 12.79, sorry. And you can see it's climbing, 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 and the question really is, when is it gonna stop climbing? This is what we want to know. When will it consider the battery to be fully charged? We're at 13.25, 13.3. We've got a way to go. Probably about 14.4. We're thinking of it's going to stop, or will it stop? I noticed that from the design of this, because I've looked inside the electronics, is that with the micro they're using and the electronic, the divider, there's a potential divider resistor network, which is, you know, 1%, 2% accuracy. So overall, you know, we're talking about plus or minus 0.2 volts accuracy, and you can see that from there because the actual voltage, according to the accurate £3,000 test instrument, is 14.53 up here, and if you look on the display of the battery charger, we've got 15, and we know it's accurate because the sense wires are taken direct from the battery charger terminals. There's no requirement or adjustment needed for a drop in the wires. It's all done by the sensing wires. And then you can see, look, it stepped down here to one level when you got to 14 point, what was that? We can run that bit again, actually. Yeah, you would expect it to cut off about here, 14.4, and it looks like it dropped down at 14. So there's 14. So at 14 volts it dropped down, and then it when it got to nearly 15 volts, it dropped down another level, and then when it got up to over 15.5, 15.6, we saw that it decided it's fully charged, so it stepped down, and now we're running at 60 milliamps. So 70 milliamps, between 60 and 70. What's it say on the Yoko? Yeah, it's 67 milliamps round about. It's fluctuating slightly. This is why we're getting this change up here. So now we're in the float section now. We're floating, all right? So we're floating along, and the thing's just pumping in 70 milliamps into the battery. And as it floats, the battery voltage is going to come down like a charged battery. It's going to drift down to the 12 volts, which would normally happen over the space of probably a few hours, depending on the temperature after you take the battery off charge. I mean, it's important that we don't keep a lot of current going in the battery to basically hydrolyze the acid, and then you'll boil all your electrolyte off. So that's bad. So here we go. It's a fairly boring section, actually. It's still stuck at 70 milliamps. The battery voltage meter on the charger is saying 14.5. The actual voltage is 14.2, so it's 0.2 out. So it's quite a lot, actually. But nevertheless, you know, because the temperature would vary, we're at room temperature. It's quite cold in my house, actually, but we're at room temperature. So, yeah, I don't know. There's nothing happening on the current, look. So the current's just ticking along at 70 milliamps. So we're drifting down, and we've got down to 14.05, and a normal battery sort of freshly charged would drop quite quickly to around about 13.6, 13.8. So we're going down, and my phone is ringing, wherever it is. Where is it? There it is. I'm going to pause this until something starts to happen. Well, I'm back again, and we're at 13.65, and we're still at 70 milliamps, 70.07 amps. It looks like it never gets away from it, and you can see it has just... we've changed onto the trickle section now, where we're going down to 13.3 from 13.8. That's what that little step is there, because we've got 13.6 up here, and it's actually comes down. Next step, it starts at 13.8. So that's what that small jump is, and we're still going at 70 milliamps. Now, when this gets down to the end of this section, we will then go on to support charge, where the voltage will start to dip down, and this is to simulate someone taking a load out of the battery. You know, caravan with the light on, perhaps a couple of amps coming out. We're going to load the battery with maximum of 5 amps here, and watch the voltage go down. And what we want this to do, this battery charger to do, is to kick back in and support our battery. You know, it's no good if you leave the light on and the charger is attached in your caravan, you forget to turn the light off. It's no good if your battery just gets lower and lower and lower and the charger never really kicks in with any power. So let's just see what happens there. I don't actually know what's going to happen. Right, so back again. We are... Where are we at? We're at 12.58, so this is coming down to the stage now where the battery's really starting to get some support. Down below 12.1, we're going down to 10.5, look up here, so we're starting at 13.3, 10.5 over 200 seconds, and at some point in the next minute, probably, we should start getting some support, and we have. We've got 0.8 amps. You can see that the current has now stepped up. It's quite small down here, if I show you on this. 0.8 amps, and we're down to 12 volts. Now the battery dips below 12, it should really step in and give it some beans now. But will it? The charger says 12.2. We know it's not 12.2. We know it's 11.8. So the accuracy of the charger is not so good when it's down the low end. They don't track these cheap analog to digital converters, which, you know, with resistor networks, they have to be a good quality chip. It's probably only got 10-bit resolution, perhaps even 8 on the A to D. So now we should have really stepped in. That's a flat battery. That battery is getting now well below par. You know, that would represent a battery which was pretty much flat. Go down to 10.4, that's a deep discharge. So we're heading for our deep discharge region. Are we going to get any more current from the battery charger? The answer is no. Not at all, not a sausage. So it's going to finish the test in a minute, and yeah, that battery is flat. That should be getting the 3.8 amps now to give it some support. If you left a light on in your caravan or in your camper or your car, or you've gone out to a car you don't use very often, and or you've got something connected which you don't, you forgot to switch off, this is not supporting it adequately. You'd be okay if the load was less than 0.8 amps, wouldn't you? Because it would get pretty flat, but it did get down to, where are we here? Somewhere 12.1, 12.2, which is acceptable for stepping in to say, I'll give you a bit more power. So it would provide a support charge, but it wouldn't actually provide a charge for anything which was taking any more than 0.8 amps. Okay. Oh, look at that. I'm speaking in French or something. Bon plaisir. That measurement as a language brain fart. So let's have a quick look at this. Let's say, okay, we'll just dismiss that and have a look what happened. So this is the section here where we were hovering at 7.8 volts, and the thing was thinking, it does this analysis to see why or what it's connected to. I think the problem with these battery chargers is that they are designed for 6 volt or 12 volt. And having an intelligent battery charger at 6 or 12 volts is not really what you want to do, to be honest. Not really what you want to do at all. So that's the thing. If this was just a straight 12 volt charger, it'd work much better, because I know from experience, if we connect this battery charger up and the battery on your the voltage on your battery is less than 7.5, it will just assume it's a motorcycle battery at 6 volts. And you cannot do anything. You can't press any buttons. You can't get it to get dumping its 3 amps in. You know, the scenario is you come out of work and your battery's flat, or you come out in the morning, your car goes, won't start, and the battery voltage has dropped down. You want to put your charger on there and get this 3.8 amps back to work. You don't need to recondition the battery. It's not, you know, it's flat. You need to get cracking. And if this is below 7.5 in the twilight zone, so between 7.5 and 0, it'll always assume that it's a 6 volt battery, and you cannot get the thing back on track. So really, you know, how many people have got 6 volt batteries? Not many in the UK, and you want a battery charger which knows it's a 12 volt, you've been connected. And the worst thing is when it goes through all this process here, you have to wait for this process to complete or in process before you can select car and walk off. So you're going to be there for 2 or 3 minutes. If your battery voltage has dropped to between 7.5 and 10, you're going to be there for a minute waiting for this process here to complete, and then for it to start doing this pulse charging we looked at, where it was doing those pulses we looked at on the scope trace before on that thing. So really, good value for money, yes. Useful in circumstances where your battery hasn't fully discharged below 10.4. It will get back on track and give you 3.8 amps. It won't go back into a main support charge. It just goes back to the 800 milliamps. So this is wrong, really. At this point, it should put some power back into your battery to give it some charge. I suppose on the plus side, if it doesn't put too much current in, you're not going to get lots of excess gassing. Say the battery charger fails or something funny happens. But in generally speaking, this is no good for a battery which you regularly discharge, and then you want to leave the charger connected. You know, if you're using it to power a pump or something like that, then you'll only get 0.8 volts, 0.8 amps of charge back into it, and it will not step in and say, look, I need to charge you up. So I'll just give you a quick overview of the instruments. So actually, no, I'll do that earlier. You've seen it by now probably. So conclusion is it a good battery charger? No. If you've got a car, if you've got a 6 volt motorcycle or a 12 volt motorcycle, I'd say, yeah, it's pretty good. especially if it's a 6 volt, because it will always work. But if you've got a 12 volt car battery, you really don't need an intelligent car battery with a 6 volt setting on it, because the thing is confused and it doesn't know what's connected. It can't tell. The only thing this battery charger knows when you connect it is what the battery voltage is, and it will make assumptions on what that battery is, whether it's 6 volt or a 12 volt, and then it will work on those assumptions and it will never get out of them. So if you've got a situation where you run your battery flat and the battery has dropped below 7.5, you can't recover it basically. After 7.5 it will recover very slowly, but this pulsing here to get back up to 10.2 volts probably will protect the battery, but it won't get you to work. As we demonstrated in the last video, I did that testing on that Hankook battery, which is 3.5 years old, and by running it down to 7 volts, in one hit I killed it basically, and it was only flat deep, it was only dead deep discharge for an hour or two on my bench, and the capacity went from about 28 amp hours. It was a failing battery, to be fair. Went from 28 amp hours to 15 amp hours just by one discharge. One deep discharge screwed it, which is quite a surprise to me. So there you have it. AutoXS battery charger. There's the graph. You saw what it did. You can draw your own conclusions, but unless I had a 6 volt motorcycle which I needed to charge, I'd say it'd be good for 6 volts and possibly better for motorcycles, but for cars you might be worth looking for something that works a bit better and spending a bit more. I'm going to be testing the rest of them. If anybody's got a battery charger they want to put on this test, and I'm quite happy to do it if I haven't already seen that one. But I hope you found that interesting, and if you can, subscribe to this little thing down in the corner here. So there it is. It's a very quick and dirty one, just to see whether you think it's worth, or we think it's worth, buying that thing from Aldi. And I'll say it's too cheap, really. It'll do some things, but if it's your only battery charger, you're going to need another one to get the thing working. It's a little bit too clever and a little bit too flexible, not intelligent enough to actually work properly with both types of battery, i.e. 6 volt, 12 volt, motorcycle and car. So get yourself a car battery charger, is my advice, instead of one that's designed a jack of all trades, as they say, a master of none. That's me signing off.